Okay, so in this lecture we are going to discuss about different types of sets, and then we'll see their definitions, and we'll also basically look up several examples and identify which type of the set is that. So we'll be discussing all these types of sets. One is finite set, what is finite set, infinite set, empty set or null set. Fourth one is singleton set, equal sets, equivalent sets, disjoint sets, and overlapping sets. So we'll see each and every one in detail one by one. So let's pick up the first one, that is the finite set. So as the name basically already says that finite sets. So a set of elements which are the finite in number, right? Such type of sets would be called as a finite set. Basically we can count and tell that these are the numbers, total number of elements present in this particular set. So that set would be called as a finite set. Just go through the definition. A set in which the processes of counting of elements surely comes to an end. Basically it means that you can count the total number of elements present in a set. So that would be called as a finite set. Say for example, set of all the natural numbers less than 1000. Set of all the natural numbers less than 1000 would be starting from 1 to 999. So basically we know that there would be total number of 999 elements in this particular set. So this is a kind of finite set. Another example, set of all integers between -1000 to +1000. So again we know that there are definite number of elements present in this set. So this will also be a finite set. Third example, set of all the persons present on the earth. You know that we always have the census, and we know that how many people are present in the whole country or in the whole world. So definitely we can count the total number of the elements or the total number of persons in the world. So definitely this is a finite set. Another example, set of all the multiples of 5 less than 5000. So is this a finite set or infinite set? Obviously, because you have written the condition as less than 500, right? So there will be several multiples of 5, right? 5 multiples of 5 would be 10, 15, 20, 25, 30 up to 5000. But still these are all the numbers and we can count them. So this would be kind of a finite set. Moving to the next type, that is infinite set. As the name says, that we cannot define or we cannot identify the total number of elements present in a set. That would be called as a infinite set. So a set which is not finite will be called as an infinite set. So say for example, set of the natural numbers. So the natural numbers starts from 1, 2, 3, 4 up to infinity. So up to we are reaching up to infinity. So we don't know that how many total number of elements present in this set. So we'll call this as a infinite set. You should also remember, as I already have told in the previous lectures, that n is represented for the natural numbers. Similarly, W is represented for whole number. Whole number is are those numbers where we have all the natural numbers including 0. So again you can see that these are all the sets where the numbers are reaching to infinity. It means we don't know that how many numbers number of elements present in this set, so it is again an infinite set. Similarly, set of integers. Here also we are having the elements from minus infinity to plus infinity. So we don't know how many elements are present in this set. So this is again an infinite set. Again, one more example, set of all points in a line segment. So we can figure out infinite number of points present in a line, right? So again, a set having all points in a line segment is an infinite set. Moving to the next set, that is pretty much important and conceptually it should be clear, that is empty set. So empty set is such a set where there is no item present or there is no element present in that set. Then we say that this is an empty set. So a set having 0 elements is called a empty set or null set, or sometimes we also call it as a void set. But mostly it is basically pronunciated as a null set or the empty set, and we basically represent it as a phi. So phi is known as kind of an empty set, and if you want to describe it in a roster method, then you need to write it like this: curly braces with no element. So this is called as an empty set. Say for example, there is a set X such that X is a natural number which lies between 2 and 3. So think about it. Can you find out any natural number between 2 and 3? So 2 is a natural number, 3 is a natural number, but there is no other number present between 2 and 3. So obviously there will be no number present. So there will be no element in this set. So it would be basically, this set would be kind of a empty set or null set. Another example, X such that X is as a natural number and X is not equal to X. This is the condition. So you know that there is no natural number which is not equal to itself. All the numbers are equal to itself, right? So this particular set will be having no element, right? So this is again a empty set. One more example, X such that X is an integer where X is square equal to -1. You know that whenever you basically take the square of any number, it becomes positive, right? If I say square of -1, what it would be? This would be 1. Square of 2, this would be 4. But here in the condition says that square of something is -1, which is never possible. It means there will be no value of X which will satisfy this, right? So it means there will be no value of X. It means it is a null set. Correct? Moving to the next type of set, that is the Singleton set. So a set containing only one element is called a Singleton set. If there is any set in which there is only one element present, then we'll say that this is a Singleton set. So say for example, here we have written as this set, a set containing 2 as elements. So this is Singleton element, Singleton set. Similarly, a set containing only element as A. So this is again a Singleton set. One more example, X says that X plus 2 equal to 5 and X belongs to N means natural numbers. So if you see that X plus 2 equal to 5, then only the value of X can be X equal to 3 can satisfy this condition, right? If you put 3, then 5 equal to 5. But there would be no other value of X except 3. So in roster form this would be like this, and this is there is only one element present in this, so it is a Singleton set. Similarly, another example, x plus 1 equal to 0. So only x equal to minus 1 can satisfy this, right? No other value of x can satisfy this, or no other value except minus 1 would be in this set. So this is again a singleton set. Moving to next type of set, that is the equal set. So suppose there are two sets, A and B. So we'll say that both sets are equal if all the elements in set A and all the elements in set B are same. Then you will say that both the sets are equal. And if both the sets are equal, then we can write an expression like this, that A equal to B or B equal to A, both are same, right? So if all the elements of A are in B and all the elements of B are in A, then both the sets are the equal sets. Or you can say that basically both have the similar same elements. So say for example, we have written a set as A as minus 3, minus 2, 1, minus 3, minus 2, minus 1, 0, 1, 2 and 3. And there is another set B where we have that x equal to I. I is basically all the integers where x square is less than 10. If the x square is less than 10, so can you figure out what would be all the values of x for this condition where x is an integer. Integer means it can be minus infinity, minus 3, minus 4, minus 2, minus 1, 0 and 1, 2, 3, 4, 5 to infinity, right? So if we look at this condition, then probably the value of x can be if we write minus 3, the square of minus 3 would be 9, which is less than 10, right? Minus 2, the square of minus 2 is 4, which is less than 10. Minus 1, same as that, 0, 1, 2, 3, and that's it, because square of 4 would be 16, which is greater than 10. So B also has the same elements as A has, right? So it means that we can say that A is equal to B, or both the sets are the equal sets. Take another example. C is a set where x says that x is a letter of the word follow, and another D is a set where x says that x is a letter of the word wolf. So let's basically write these sets in the roster form. So the C would be F O L W, right? Because in the roster form we write all the distinct number of items or distinct number of elements. What about another one? Wolf, W O L L F. So you can see that C also has the same elements and D also has the same elements. Here we have WLF, WOL, WOLF. So it means that both have the same number of elements. So these and C and D are the equal sets. Got it? Okay, so before moving further, we also want to discuss one more concept, that is the cardinal number of a set. So cardinal number is nothing but the number of items or the number of items present in a set is called the cardinal number, or the number of elements which are present in a set, that is the cardinal number of the set. Suppose there is a set which is having the elements as 1, 2 and 3. So how many elements are present in that set? 3. So 3 would be kind of its cardinal number. So the cardinal number is the number of distinct elements contained in a finite set is called the cardinal number. We denote it by n, na. A is the name of the set and n is kind of the representation of the number. So you can say na is the cardinal. This is kind of a representation. So suppose you have a set as A as 2, 3, 5, 7 and 11. So how many elements are present in this set? 1, 2, 3, 4 and 5. So the cardinal number of this set would be 5. Correct? Similarly, suppose we have a set B as 1, 2, 3 and 6. So how many elements are present in this set? 1, 2, 3 and 4. So the cardinal number of this set would be 4. Yes, this is pretty much interesting. Cardinal number of null set. So we have just basically discussed about what is null set. Null set is such a set where there are no elements present in that set, right? So if there are no elements present in this in that set, it means its cardinal number would be 0. So the cardinal number of empty set is 0. You must understand this. Moving to the next type of set, that is the equivalent set. So equivalent set of, suppose there are two sets, set A and set B, we'll call those both sets as the equivalent if the cardinal number of both the sets are same. Cardinal number of both the sets are same means the number of elements in set A and the number of elements in set B are same, then we'll say that these two sets are the equivalent sets. And we represent the equivalency symbol as like this, that A and B are the equivalent sets. Okay, sounds good. So just say we have two sets. A is this, which is containing the elements A, E, I, O and U, and B is another set which is containing the elements 1, 2, 3, 4 and 5. So what is the cardinal number of set A? How many elements are present in set A? 5, right? And what is the cardinal number of set B? There also we have the same number of elements, correct? It means the number of NA and NB, number of elements in set A and number of elements in set B are same. It means A and B are the equivalent sets. So you should be clear about the equivalent sets and the equal sets. Equal sets are those sets where the number of elements as well as all the elements are same in both the sets, correct? But in equivalent sets, we are not looking into the elements, we are just comparing the total number of elements. Okay, just take an example, right? So set A has been given as X, as that X is a letter in the word football, right? And B set is given as like this, that X is as that X is a letter in the word cricket. So let's write in the this set A in the roster form. That would be F O T B A L, right? And what about B? C R I. We will not write C again because this is duplicate. K E T. So how many elements are present in set A? 6, right? And how many elements are present in set B? 6, correct? So because the cardinal number of both the sets are same, so it means we can say that A and B are the equivalent sets. obviously, right? But you can see that number of basically elements present in A and elements present in B are different. So these are not the equal sets, but these are the equivalent sets. Moving to the next type of set, that is disjoint set. So suppose there are two sets in such a way that there is no element is in common in both the sets. Then we'll say that these are the disjoint sets. Two sets having no elements in common are known as the disjoint sets. Suppose a set A is a set is containing 1, 3, 5 and 7, and set B is containing 2, 4, 6, 8 and 10. You can see that here it is containing the elements this, and in B it is containing the elements in like this, but none of the elements is common, right? None of these elements is present in A, present in B, and none of the elements of B is present in A. So these two sets A and B are called as disjoint. No any element is in common. Right? Moving to the next type of set, that is, okay, let's check one more example. A set of A, suppose A is such a set where X is a vowel in English alphabets, and another set B is such that X is a consonant in English alphabets. So you know that vowels and consonants are different, right? Vowels are A, E, I, O, U, and consonants are all those alphabets in English which are not containing the vowels. So here we'll say that A and B both are the disjoint sets. Moving to the next type of set, that is overlapping set. So overlapping set says, suppose there are two sets in which at least one element is in common. We can have more elements in common, but there should be at least one element which is in common. Then we'll say that okay, these two sets are the overlapping sets. So going by definition, two sets A and B are called overlapping sets if they have at least one element in common. So in the example below, if we see that set A has element 2, 3, 5, 7 and 11, and set B has element 2, 4, 6, 8 and 10. So if you see, then we can see that element 2 in A and the same element is present in B. So this is at least one element which is common in both the sets. So we'll say that both A and B are overlapping sets. If I remove 2 from A, then there are no any other element which is present in set B, right? So in that case, if 2 is removed from set A, then these two sets will become disjoint set. But because 2 is in common both, so as of now both are the overlapping sets. Another example, there is set C with the elements A, B, C, D, and there is another set D with the vowels A, E, I, O, U. You can see which elements are in common. We can see that A is a common in both, E is also common in both. So we have got two elements in common. So it means C and D are overlapping sets. Correct?